As we've discussed throughout this class, solar energy is the primary source of energy driving biological life on Earth, sustaining not only humans but the entire ecosystem with photoautotrophs that serve as primary producers. Despite only about 1 billionth of the sun's energy penetrating and reaching the Earth's surface, this fraction surpasses global energy requirements. It's noteworthy that virtually all energy sources, whether renewable or non renewable, are essentially stored forms of solar energy. For instance, wind, a renewable energy source, derives from the sun's uneven heating of the Earth's surface, while non renewable energy sources like oil are the result of fossilized marine algae, which harnessed solar energy millions of years ago. Our focus in this section will be on the direct utilization of sunlight as an energy source, which we refer to as solar energy. Throughout history, solar energy has served as an approach for heating homes and water for thousands of years across many different civilizations. Examples include ancient China, where Neolithic homes were constructed with south facing orientations, harnessing the lower angled winter sunlight to provide warmth. Similarly, the Romans ingeniously utilized solar energy by integrating expansive south facing windows, crafted from materials such as glass and mica, to heat the interiors of their bathhouses. The image depicted here is of a 4,000-year-old bathhouse that served a small fishing village unearthed along a Spanish beach. Modern times have evolved with the advent of photovoltaic cells or solar panels, enabling the conversion of sunlight into electricity, which can be used for a variety of industrial applications as well as domestic use. In 2022, solar energy contributed to 14.2% of the United States renewable energy consumption, which represents less than 2% of total energy consumption, primarily through solar panels. Solar energy's global distribution is uneven, making some regions more suitable for investment than others. Additionally, solar energy generation is limited to daylight hours, rendering it ineffective at night and on cloudy days. Battery storage for solar energy remains a technological challenge despite its vast potential. Nevertheless, solar power usage is experiencing rapid growth as an alternative energy source, driven by a remarkable decrease in the cost per watt as manufacturing techniques advance and government incentives become more prevalent. This progress is clearly reflected in the surging popularity of rooftop solar panel installations. Solar power can be categorized into two main types: passive and active. Passive solar power harnesses the sun's energy to provide heating and cooling without the need for special devices or advanced technology. Passive solar space heating, for instance, occurs when sunlight enters a building through its windows, effectively warming the interior. In the northern hemisphere, buildings designed to optimize passive solar heating often feature south facing windows. These windows are strategically positioned to receive ample direct sunlight during the winter months when the sun is lower in the southern portion of the horizon. This passive solar heating relies on natural processes such as radiation and convection to heat the building. Such buildings are typically constructed using materials with high thermal mass. So these are materials with a lot of mass. They can hold a lot of heat, like bricks or concrete, which can trap, absorb, and store the heat. As the temperature drops at night, these materials gradually release the stored heat, ensuring the building remains warm. During the summer, window overhangs or shades are employed to block the sun's rays from entering the windows, thus keeping the building cool. An example is this image that highlights the remarkable achievement of Darmstadt University of Technology in Germany, the winner of the 2007 Solar Decathlon held in Washington, D.C. They designed a passive house tailored for the hot and humid subtropical climate. The clever architecture here includes windows that enable passive solar space heating when required, And large shutters equipped with large slats you can see here that are fitted with solar photovoltaic panels. These panels ingeniously convert the blocked out sunlight into electricity. Unlike passive solar power, active solar power systems utilize specialized devices to transform solar energy into other forms. One common example of an active solar device is the solar photovoltaic or PV cell, also known as a solar panel, which directly converts sunlight into electricity. PV cells function by employing semiconducting materials such as silicon, which generate an electric current when exposed to sunlight. Small PV cells have the capacity to power small electronic devices, including lamps and watches, while larger arrays of PV cells can produce electricity for an entire house or business. It's worth noting that millions of houses and buildings across the globe have adopted rooftop PV systems. Moreover, there are large scale solar PV power plants, often referred to as solar farms, like the Solar Star solar farm in Southern California, the largest of its kind in the United States. The Solar Star solar farm, covering 3,200 acres and featuring 1.7 million solar panels, produces enough electricity to power over 250,000 homes. An additional active solar power device to consider is the solar thermal collector. These collectors utilize the sun's radiant energy to heat coils or pipes, typically containing fluids. Pumps are used to direct the heated fluid into the building's interior, or the heated fluid circulates through a storage tank for later use. There, the heat is released before cycling back to the collector for reheating. Collecting thermal energy from the sun can even be used in larger formats for the generation of electricity. Solar thermal systems concentrate sunlight to generate high temperature heat to generate electricity. The key components of solar energy collectors include reflectors or mirrors and a receiver. Reflectors are responsible for capturing and concentrating sunlight onto the receiver. The receiver's primary function is to heat a fluid, following a similar process to that of a conventional power plant, such as that of coal or nuclear power. Only this fluid is typically a molten salt that can handle extreme heats exceeding 500 degrees Celsius, allowing for higher efficiencies and lower costs. Once heated, the fluid generates steam in a steam generator. The steam in turn serves to rotate a turbine. This rotation powers a generator, leading to the production of electricity. To maximize efficiency, solar thermal systems incorporate sun tracking mechanisms, ensuring that sunlight remains focused on the receiver throughout the day. The Ouarzazate Solar Power Station, also known as the Noor Power Station, is located in Morocco and is the largest solar thermal project in the world, with a power generation capacity of 510 megawatts. This project came with an estimated total cost of approximately $2.5 billion. The major benefit of solar thermal plants is the storage of the sun's energy as heat in molten salt allows the production of electricity even during the night, much how nighttime heat emission is used in passive solar energy use. Furthermore, the subsequent phases, NOR 2 commissioned in 2018 and NOR 3 commissioned in 2019, offer extended energy storage up to 8 hours. The solar power station spans an expansive area of approximately 6,178 acres, marking a significant step in harnessing renewable energy sources. The expansion of solar energy is not solely driven by environmental concerns, but is primarily fueled by cost reductions. This graph illustrates the levelized cost of energy, or LCOE, comparison, which takes into account all costs, from initial construction and operation to maintenance and more. Across the board, renewable energy sources have witnessed significant drops in cost per megawatt hour, MWH, of energy produced. To the far right, you'll find each category listed from top to bottom as depicted in the 2023 line graph. Notably, nuclear energy, despite a 47% cost reduction per megawatt hour, has been the most expensive energy source due to the substantial initial construction costs and the governmental regulations. On the other hand, the most cost effective energy source, the bottom, currently is onshore wind energy, a topic we'll explore later in this chapter. Just slightly above onshore wind energy is utility scale solar voltaics, differing from residential rooftop solar. And since 2009, the price per megawatt hour for utility scale solar PV has declined by 83%, mainly owing to manufacturing efficiencies. As mentioned earlier, renewable energy sources, including solar energy, have a significantly lower environmental impact compared to fossil fuels. Solar energy generation does not emit greenhouse gases or other airborne pollutants. However, it's important to note that solar energy is not entirely devoid of environmental impact. An environmental consideration associated with solar energy involves the physical placement of photovoltaic cells. The impact of the environment varies depending on where these cells are located. PV cells are commonly installed on rooftops, over parking lots, or integrated into building structures, resulting in negligible environmental impacts. However, larger solar systems and solar farms may be established on extensive land areas, often in desert regions, potentially posing a threat to fragile ecosystems. In addition, certain solar thermal systems employ heat absorbing fluids that may be potentially hazardous and require appropriate handling and disposal procedures. The manufacturing of PV cells also generates hazardous waste due to the use of chemicals and solvents. Furthermore, decommissioned solar panels can be considered hazardous waste due to their heavy metal content, necessitating special measures during recycling or disposal to prevent environmental contamination. Despite these environmental drawbacks, PV cells maintain a substantially lower environmental footprint compared to conventional energy sources, a factor that has fueled the rapid growth of the solar energy sector. In the subsequent section, we will delve into another fast growing renewable energy source, wind power.